Welcome back, guys. So we have understood what data science is. I'm sure many of you had questions as to some, let me call them weird words like regression analysis, the Bayesian inference. But today we are going to dig a little bit deeper about regression analysis, and then we look at the correlation between regression analysis and data science. You see, data science is big field, and there are so many approaches that we do with data. Wale walisema mwalimu wa maths aliwaambia hawatafika hapa, mmefika hapa. When you work in that organization, when you work in that company, you deal with data. Inaweza kuwa you're collecting some basic information, or you are dealing with heavy information. You are processing maybe heavy data from somewhere that is a certain input is a certain output is needed. So let us understand first what is regression analysis, what it does, and how do we use it to unlock what you call the secrets hidden in data. So if you have not connected with us, kindly hit the subscribe button, because we're just getting started. There's so much to learn, so much to talk about. If you have any questions, just click use the comment section. Now let us begin. So in this video, I'll talk about regression analysis, understand what it is, mention maybe a little bit different types of regression analysis. Then we look at data preparation for regression analysis. We also understand how to interpret regression analysis results, and then look at the real-life applications of regression analysis in data science. By now, I'm sure we have understood what data science is and what it does. If you have not, kindly refer to the previous video and then join us. Good. Well, regression analysis basically it's just a technique in statistics that we use to model the relationship between two or more variables. Now, why is it a powerful tool in data science? Because it allows us to make predictions and identify large patterns in data sets. And then when we analyze this relationship between different variables, we now gain insights into complex systems, and we can make informed decisions based on data-driven evidence. Well, this regression analysis can help us understand how changes in one variable affect another. And now, which is particularly useful like in fields like finance, marketing, healthcare, even in government. There's so many fields you can apply this. But before that, let us just have a quick insight of what is regression analysis. As you have said, this is a statistical method that is used in data science to identify the relationship between a dependent variable and one or more independent variables. It helps us understand how changes in one variable affect another. Wait a minute, we are not talking French here. When I say independent variable and an independent variable, I can say, for example, you want to understand that how changes in temperature, for example, can affect the sales of ice cream. Now we could use regression analysis to determine whether there is a correlation between these two variables, and then when you analyze the data, we might find that as temperature increases, so do ice cream sales. Now this insight can help businesses plan the inventory and make marketing strategies accordingly. What are we saying here? Because we have understood that regression analysis is about trying to identify the relationship between two or more variables which are independent. And we have given a good example of you want to understand how, as the temperature rises, it affects the sale of ice cream. A good example is you have an ice cream business, and you realize that whenever the temperatures are hot, it is sunny, your ice creams are just you're really selling. And then maybe when the temperatures are low, the weather is maybe winter or cold, you realize your sales drop. Now for you to plan accordingly from these insights that you have understood or you have made from your business, you can be able now to plan and understand maybe the weather, maybe tomorrow will be sunny or it will be cold. You can know that tomorrow I'll make maybe these types of sale, and you can project the types of sales you can make or not. So that is what we are trying to say. That is regression analysis. Now when you do that relationship between those two independent variables, and then uh, what are these maybe types of regression analysis? I'll start by saying uh, I'll start by what you call the linear regression. Linear regression, this actually is used model to it's used to model the relationship between two variables. Now, this type of regression is useful for predicting outcomes based on a single predictor variable, such as how changes in temperature affect crop yields. Now, let us dive into agriculture. You are in the Ministry of Agriculture or some NGO or business that deals with agriculture. Now you are looking at maybe how, for example, different changes in temperature affect the crop yields. At what point do you get higher yields and low yields? That is that type of insight and outcome is what we call linear regression. Now this is where we can use this linear regression to predict outcomes based on this single predictor variable. And this is here now what we call the crop yields. We'll now understand, let's say, at what point do we get higher yields or low yields. Going on, we also have this what we call multiple linear regression. This one can allow us to model the relationship between multiple predictor variables and a single outcome variable. It's very good to identify the differences between these two types of regression, because in this type, regression is useful for predicting outcomes based on the combination of factors such as how changes in advertising spending, pricing, and product features affect sales. Does it mean that when you spend more on advertising, how what is the impact on your sales? Do you do more sales or low sales? So it that an example is what is called multiple linear regression. And then when you look at something like logistic regression, this is when the outcome variable is binary. What does it mean by outcome variable is binary? It can only take two values. And then this logistic regression is commonly used in marketing and healthcare to predict whether a customer will make a purchase or a patient will develop a particular condition. Good. Now let us become doctors here. You are in a hospital. Now you already know maybe certain symptoms. There are some symptoms which lead to maybe a certain condition. So once you have collected maybe patient data and you are seeing maybe there are some symptoms that are of a particular nature, and then you can use what you call linear logistical regression to determine whether the outcome is variable, meaning it can only take two values. No. So you'll use that, for example, the patient previous information to determine whether this patient will develop a particular condition, and maybe get maybe some way to prevent that from happening. So those are the types of regressions at this stage. We're just highlighting, we'll dig deeper as time goes. Yeah, so then what about data preparation for regression analysis? Now, before we dive into regression analysis, let us first understand when we want to do regression analysis. Now we are on the actual part of doing it. We're in the do. We were understanding first how. Now we are in the do. Before you dive into regression analysis, first ensure that your data is clean, organized, and ready for analysis. Let me make an example of what you do maybe almost daily. Have I said we are talking about various businesses here. You are in your daily routine of capturing some data. You can be capturing, for example, in a hospital health records. If you're in a certain company dealing with a certain product, maybe you have product information, you have maybe client information. There's so much that you can do with that information. Now, before you even type now to start doing some regressional analysis on it, you need to first get your data to be clean. A good example of what I mean by clean data. If it is Excel, for instance, do not mix maybe date characters and numerical characters and character maybe values in one column. You see, it becomes almost impossible for you to perform some basic to apply some basic formulas for faster analysis on them. And then when you talk about clean and organized data, uh, they say in statistics and also in programming, when you type with in caps, it appears like you are shouting. So you can organize your data so that even when you look at your report, it is clean. So we are emphasizing here on clean, organized, and ready for analysis. Ready for analysis is that, for example, if it is in Excel and that column is for date variables, you have not mixed date variables and maybe name characters of character values, and maybe other numerical, maybe you're capturing IDs or something. So now you have different types of character variables, or I mean different types of data types in one column. Now you cannot even apply some formulas on it. That is what I mean by clean, organized, and ready for analysis. Ensure you have good data, because sometimes poor data quality can lead to inaccurate results and flawed conclusions. Therefore, data preparation is a critical step in the regression analysis process. Now that is the first step. Now, to prepare our data, we must start by identifying and addressing the missing values, the outliers, and other anomalies. We may need to impute missing values or remove outliers to ensure that our data is accurate, represents maybe the population. Additionally, consider transforming variables to meet the assumptions of the regression model, such as normalizing skewed distributions or taking logarithms of highly skewed variables. Finally, split your data into training and testing sets to validate your model and prevent overfitting. By training and testing set is that you be able to test your data if it can do what you actually uh, meant it to do. And then we have some common pitfalls maybe we need to avoid during when you're doing data preparation. This includes failing to check for missing values and the outliers. So you need to understand what outliers you need, and using incomplete or inconsistent data, and failing to properly transform variables. Now, by taking the time to prepare your data correctly, you'll be able to obtain more accurate and reliable results from regression analysis. Now, let us now talk about when now we're interpreting. How do we interpret the regression analysis results? Uh, we know that regression analysis can provide valuable insights into the relationship between variables. You see, the whole point here is the relationship. We're trying to see what relationship are these variables have. But interpreting the results can be challenging, because coefficients represents the strength and direction of the relationship between the independent and dependent variables. Also important to note, you should be able to know what your independent and dependent variables are. Then a positive coefficient indicates a positive relationship, while a negative coefficient indicates a negative relationship. Now, the p-value measures the statistical significance of the relationship. A low p-value indicates a strong relationship that is unlikely to occur by chance. The r-squared values measure the proportion of variation in the dependent variable that can be explained by the independent variables. A high r-squared value indicates a strong fit between the model and the data. However, it is important to remember that correlation does not imply causation. Just because two variables are strongly correlated does not mean that one causes the other. Okay? Just mean, for example, just mean because there is high temperature doesn't mean you'll always be selling your ice creams. Okay, so now what applications can we do with regression analysis in data science? As we have seen, these are an incredibly powerful tool in data science, and that can be used to predict customer churn, analyze market campaigns, and forecast sales. By analyzing historical data, regression models can identify patterns and relationships that can help businesses make better decisions. For example, a company might use regression analysis to predict which customers are most likely to churn, and then develop targeted retention strategies to keep those customers engaged. Or a marketing team might use regression analysis to identify the factors that drive campaign success and optimize their spending accordingly. Or a sales team might use regression analysis to forecast future sales based on historical data and adjust their strategies accordingly. Here we have seen that it's all about making valuable insights from a relationship between two aspects. And this usually is concerned with what you do. If your business maybe is dealing with farmers, an example, you should be able to know what farmers want. If farmers maybe want certain type of crops, and does it mean that when you provide these types of crops to farmers, uh, do you get more? Do you bring more farmers on board, or you lose more farmers? For example, when you give maybe certain crops as incentives to farmers, does these crops enable you to recruit more farmers on board or not? The transport sector, for example, even when governments maybe are making some passing some laws and aspect. This is just an example. Does it mean, man, maybe when a certain decision maybe is made, or a certain way of doing things is done, do you get maybe more smooth operations in transport sector or not? There are so many things that you can do, but now you need to understand what regression analysis can do to data science, and that gives rise to what we call a mature modern way of doing stuff. Because when you employ predictive analysis in your business, you're able to model and forecast what is going to happen to your business few weeks, few months ahead, depending on the relationship you are seeing. Maybe the relationship between how you perform or how you interact with your clients. Then you'll be able to forecast how your business is going to perform in the next few months. So for now, I think we'll conclude with that regression analysis. Maybe you can do a recap later to understand more detailed aspect of it. But this was just a beginning, to just an introduction to regression analysis and the correlation it does with data science. For now, I'll leave it to that. In case you haven't watched my previous videos, there's Excel, basic understanding to Excel, there's Python and R. We can dig deep there as we try to become data scientists. See you next time.